Hello guys, this is the first video notes, and this video actually Math 2 and Math 3. Most of them won't be like that, but this one is adding and subtracting polynomials. So where we're going with this is for Math 2, we're going to review the basic adding and subtracting polynomials, then we're going to get into quadratic equations. For Math 3, we're going to review that same stuff, adding, subtracting, multiplying polynomials. Then we're going to get into more fancy stuff with polynomials, like bigger polynomials with x to the fourth and x to the fifth, graphing those, solving them, dividing polynomials, stuff like that, which will be the whole quarter pretty much. So we go in a little different places, but we're going to start off with this video that will be for both of you guys. So rule number one with adding and subtracting polynomials is only like terms can be combined together. So 7 dogs plus 3 cats doesn't equal 10 dogs, because dogs are not the same thing as cats. So you have to keep those separate. You can't add them together. Same thing with x's and y's. 6x and 2x are like terms because x's are the same thing as x's. So you can combine those two terms to get 8x, but the 3y you can't combine with that because y is not the same thing as x. Also, x squared is not the same thing as x. So you can't add 6x and 4x squared and get 10x or 10x squared. No. So make sure when you're adding pieces together that they are like terms. And we'll do some examples in a minute, but first we're going to go over some vocabulary and stuff. So first of all, what is a polynomial even? Well, it's an expression made up of monomial terms being added together. So terms are things that get added together. An expression is something that doesn't have an equal sign. So if you put two expressions together with an equal sign between them, then you have an equation. But yeah, a polynomial is a bunch of monomials added together. So what's a monomial? A monomial is something made up of a power of a variable, so like an x with some kind of exponent on it. X would be the variable, that 3 would be the exponent or the power, and then it can be multiplied by a number. So the 5 with the x, 5x, 5 would be that number, and the 5 is called the coefficient, which we'll get to in a minute. And there could also possibly be variables with other variables with exponents, so like 5xy, which we won't do too much with at the moment, but I'll talk about that more in a second. So that's what monomials are. Add 2 together and you get a binomial. Add 3 together, you get a trinomial. And whether it's a monomial, a binomial, a trinomial, or if there's a whole bunch of them all added together, like 5, those are all polynomials. Okay? And polynomials, so what would not be a polynomial if it has other stuff than what I just talked about? So if it's got divided by a variable, or sine or cosine or log, absolute value, if it contains any of that stuff, it's not a polynomial. It can only be variables with powers multiplied together with constant multiplied together and those terms added together. So I had to restart my video, so I already circled and crossed off which ones are polynomials, which ones aren't. So you don't get to see me do it. But this is a polynomial because all those parts are monomials. This one was not a polynomial because it has divided by x. Same thing with this one, divided by x on the bottom of a fraction. That makes it not a polynomial. Even though these are just simple monomials, they're still called a polynomial, even though it's just one. These two, that's what I was mentioning. We're not going to deal too much with that, but those are also polynomials, even though there's multiple different variables involved, x, y, and b. That's okay, it still can be a polynomial then. Sine of something, not a polynomial. Okay. One important vocabulary polynomials is degree. So each term has a degree and the polynomial has a degree. So the degree for the polynomial is the largest exponent on a variable in the polynomial, except you count it a little differently on things like this, but we won't worry about that right now. But so this example, there's x to the fourth and x squared. 4 is the biggest exponent there on the x's, so this would be a fourth degree polynomial. This one right here would be a second degree polynomial because of the x squared is bigger than x to the first power. If there was no x squared, 3x plus 5, that would be a first degree polynomial, right? Because x is really x to the first. Okay, standard form is when you simplify it as much as you can. So add any terms together that can be combined. So they're all the like terms are combined together, and then you put it in order from the highest degree to the lowest degree. So this is the standard form of that, because the x squareds we combined together, and then we put it highest power down to the lowest power on the variable. So yeah, this would be a second degree polynomial, by the way. Yeah, so fully simplified and then ordered from highest degree to lowest. So that is the second degree term, first degree term, 0th degree term. Highest to lowest. Again, sorry I circled a bunch of stuff on here already, but a coefficient is the numerical factor in a term. So let me start over with this. X cubed minus 7x squared plus 3x minus 4. All right. So there's 4 terms. That, and that. The coefficient on that term is a 1, because really that's 1x cubed. The coefficient on that term is negative 7, not 7. Coefficient on that term is 3, and that's not really a coefficient because it's the constant term. So the coefficient is the number in front of the x to a power, or whatever the variable with the exponent is. The leading coefficient is the first one. So you put it in standard form. What's the number in front of the biggest power of x? Notice there could be a bigger number. 8 is bigger than 6, but it's on x with a smaller power. You want the number with the x to the biggest power. So just put it in standard form first, then look at the front. That's the easiest way to make sure you don't mess anything up there. All right, 2 quick examples. First one, adding polynomials. So I'm going to show it 2 ways. You can write it whichever way you want on your paper. So horizontal, I first get rid of the parentheses because the order you add things in doesn't matter. Then I put the x squareds all together at the front. Then I move the x's together at the middle. Then the constant terms at the end, added the like terms together, and got that. Vertically organizing it can be helpful, might be easier for you. You just line up the terms underneath the terms that they go with. So the easiest way is make sure this and this are both in standard form, and x squared with x squared, x with x, that with that, It got the same answer both ways. Subtracting, same deal. The only special thing here is the negative applies to this whole thing. So it's like distributive property. -1 times that, -1 times that, -1 times that. Because you're subtracting the whole thing. So you're adding the opposite. So the minus 3x squared minus 4x plus 5. And then same thing. All right, thanks for watching. Sorry I went 30 seconds or so over, but if you have any questions, you can ask me tomorrow. And yeah, have a great day.